Hi, I'm Sibusiso, and my team and I will be running you through our Brownfield development project. We're a team of four that consists of Sihle, Wanda, Gugu, and myself. Enjoy! Brownfield development is programming in an existing code base to change the functionality of the system or to add new functionality. So the code base we're working on is called Robots World. Robots World is a simulation where a server program builds a world and manages many robots in that world. So how it works is that robot connects, receive updates, and send commands to the server using a separate client program that lets users control robots and explore the world. So all the programs follow a shared protocol for communication, and the project's requirement were improving and adding new functionality to a randomly selected robots world code base, building an API, adding acceptance tests, building a pipeline, and relational. For identifying correct source files, we made use of two tools that helped us ensure the correct source files. So the first tool was Maven. So Maven is a build management tool for automating the build process and identify the necessary source files based on the project's configuration. So what Maven does is that it simplifies managing dependencies as it downloads the necessary libraries and their dependencies from a central repository and then stores them locally for your project. This ensures that everyone working on the project uses the same library versions, preventing compatibility issues. And then the second tool we used is Git. So Git is a version control system to track changes made to files over time and simplify collaboration. It enables developers to work on different parts of the code base simultaneously without interfering with each other, and then allow team members to see changes made by others. To ensure our projects use the right version of any additional files it relied on, we employed Maven's dependency management feature. This involves specifying these files and their exact versions within the project's POM file. So the POM file is created when building a Maven project. And then our team relied on Git, a version control system, to ensure everyone retrieves the same version of a file. Git also provides a workflow, including creating branches, submitting pull requests, and pushing changes for making updates in a controlled manner. It assisted in preventing conflicts when multiple people access the same file. For, for code and design conformance, we utilize unit testing and a pipeline to maintain code integrity and catch potential issues introduced by modifications. Following best practices encouraged by Maven, like using design patterns and the well-defined interfaces, contribute to more maintainable and reusable code. So we were able to successfully complete the projects on time and within scope. To demonstrate how it meets all the requirements, I'll provide a quick tour of the project's functionality. So the project has a script built in it to simplify the running different parts of the program. Since the program contains of the server, API and client side, and also unit tests, we made a script that simplifies the running process of the project. So our script takes on arguments. It's Brownfield. Takes on argument on what you want to run, and then if you want to run the server, you just pass on server, and then yeah, it will run your server. And then on our left hand side we will have the server, and then on our right hand side we will have our client program. client. As you can see, our client is able to connect to our server program without giving us any issues. And then we can also launch a robot. We can name it HAL. Give it a shotgun. And then, yeah, as you can see, our program makes use of JSON strings to communicate. So what happens is that the client sends a JSON string to the server, and then as a request, and then the server processes that particular request and then sends it to the client side of the program, and then the client side will receive the JSON string as a response. If it's a valid command, then you will get the results as okay. And then, yeah, this is how basically the structure of your JSON string you'll be getting. And then if you pass in like an invalid command, it will be sent on the server, processed, and then sent back, and the server will alert you that it's an error, the command is unsupported. And then we also have an API. So for an API, we made a program that's able to make a get and a post and a post request to the server. So for an API, we made use of Javelin 4. When you run the server, you also trigger the API program. So when you run the server, basically what happens is that the API is automatically triggered as well. So now we'll just connect our API to this program. API. SH. And now our API is triggered. Now we are connected to the server. We will be able to make like get request. We're able to get the world, and as you can see, our API is able to send through requests to the server, and then to the we are able to make a get request to the API and then receive a response. And then this is the structure of the get request we just made. If you can just copy this and then paste it on your browser, you will get a JSON string as a response as well. Same as what happened. Yeah, and as you can see, we just demonstrated that our code works properly without any problems. Our program utilizes two methods for data management. So in-memory data structures efficiently track each player's attributes and the current world state while the program are still running, and then SQL database stores various world attributes that persistently saved from the server. So we have like in-memory data structures and an SQL databases as a method of accessing data. So this is a code snippet of an in-memory data structure. So this is from our code, just to show how we use like in-memory data structures. So we have like make use of lists, make use of maps, simple variables as in integers, strings, and then many more, and many more other data structures. And then for an SQL database, we make use of SQL to store information, and this is how we access that particular information. So this is like a code snippet of an SQL server after we saved a world onto that SQL database, and then these are just values that were on that particular world on our program. The code snippets demonstrate clear naming conventions that enhance readability. The class name position explicitly conveys its purpose of representing a player's location in the program. Additionally, we have like variables. We have variables like x and y accurately reflects their corresponding data types, which is integers, and their role in storing positional coordinates. The getter method, get x and get y, further reinforce this clarity by simply retrieving the respective coordinates without unnecessary complexity. So that's how we made the program to show that names created in the program describe the purpose of the items names. So we are pleased to report that our project closely followed the design documentation established at the outset. This included implementing all planned functionalities like I previously showed, the server, the client, and with the server, the client, and the API. And then we built a pipeline on GitLab using a makefile. And then we had acceptance test, and then API have explained that. And we have a persistent database for data storage, but Wanda will be going through that with you. So now we'll demonstrate the pipeline, the pipeline and the project structure basically. So this is our GitLab, the project GitLab, and then this is like how a Maven project is structured. This is the POM file used to install all the dependencies with along with their versions. And then what I wanted to show was the pipeline. So this is what represents the pipeline, and then this is the make file uh, that describes each and every job a pipeline has to like go through in order for a commit to be pushed to GitLab. So yeah, these are like the different jobs, different stages actually. So here it just indicates that our pipeline is successful. So these are all the stages: the clean, the build, the package, the test, and then the deploy. So if one of these stages fail, then the project will not be committed to the main branch. So for now, everything is working properly, and then we have no problems with our pipeline. And then for acceptance tests, we have our test here. And then just to demonstrate how our acceptance test look, they are accompanied by stories. There's something called a story, and yeah, this is actually their implementation. I will go through stories with you later on. And then this is our launch command acceptance test. We're basically testing for each and every possible scenario that can be experienced by the launch command. The need for a dedicated testing program or test set specifically designed for stress testing should be thoroughly assessed. This is crucial considering the potential for a high user volume and the resulting surge in requests directed towards the website or API. Stress testing helps identify performance bottlenecks and potentially failure points under such heavy loads. By simulating this condition, we can proactively ensure minimal response delays for users and prevent downtime during peak usage period. Okay, like I demonstrated before, our project makes use of GitLab CI and CD pipeline to implement a comprehensive test strategy. So GitLab pipeline automates the software development cycle, allowing us to integrate various testing stages within the pipeline. So our development process leverages a makefile to define clear stages. We prioritize code quality through unit testing, focusing on individual components using JUnits. These unit tests are seamlessly integrated into CI/CD pipelines, ensuring they run with every code commit. This automated test safeguards against regression by catching issues early on. So we conducted an exploratory acceptance testing session to gain a deeper understanding of user behavior and identify potential edge cases that might not be been explicitly covered in the initial test cases. So this allowed us to refine our acceptance criteria and ensure the program caters to a wide range of user interaction. Okay, so here's like a code snippet on how we were able to resolve one of the issues the user might encounter when running the launch command basically. So here we're just checking. This is an acceptance test that checks. This is a code snippet of an acceptance test that checks if a valid command succeeds actually. So if so, what happens is that we have like code that's well documented with doc strings that has doc strings explaining what happens under that particular doc string. So if you can look at now line number 3, running a one by one server, so that's like a code for running a one by one server. And then line number 7, connecting client to the server. Given that I am connected to a running robots world server and the robot is of size one by one, they're well configured or hard coded to this size. When I send a valid launch request to the server, then this is sending a launch request to the server, then I should get a valid response from the server, and then this is making use of JUnits to check if the server is returning the expected result. So the response we're expecting is okay as a result, and then the position of the robots should be on position 0 and 0. So here we're just checking if the response that got sent back is 0 and 0, and then and I should also get the states of the robots, and then yeah, the states should also be there in like a JSON string when it returns a response. To empower users and ensure they can leverage the program to its full potential, we created a comprehensive README file. This file outlines clear instruction on how to set up, configure, and use the program effectively. And this is our README file. Immediately when you open our projects on GitLab, it will be accompanied by a read file, a README file. Okay, so here is a well-structured README file. So this is our README file. So here it just tells you what Robot World is, and then this is just a project overview, installation guide before running it, and then how to run the the project, and then different parts of the of what the different programs of what the project has actually. So yeah, this is the README that has all the information. For the project's description, that resides within the README file that we just viewed. So the project description is just here. That describes the project, and this is the overview. And then if you want to like know more about the project, you can just go through these. And yeah, that's it. Alright, so I think we have already outlined this, but then the projects include a README file containing general project information. The code base is organized into several folders. We have a dedicated folder for a server code, a client code, and an API code, and also the tests are also in separate files. This modular structure promotes maintainability and easier navigation. So if you can like go to our GitLab and then view the project, okay, main branch, and then this is our project, and then we have like a source folder, and then inside the source you have like two separate folders. So we have like the folder for the main code. So here resides the main code. It's right under this folder. And then this is the API code. The API code is found under here, the API folder. And then the client code is found under client folder. And then the database connection is found under DB connection. And then we have like folder for interfaces. These are the robots command and interfaces as well. And then this is all the code that's connected to the server, and then this is the code connected to the world. So different folders hold different code blocks actually associated with the name of the folder. And then we can go back and check out the tests. So these are like the tests for different folders as well. So for APIs, for robots, for servers, and world as well. To, en- to enhance code readability and maintainability, we heavily utilized doc strings throughout our project. So these doc strings are comments placed directly within the code that explains the purpose and functionality of different elements. So docstrines typically provide valuable information for programmers analyzing the code. This can include details like what a function does, the parameters it takes, and their expected data types, what value it returns, and any potential exceptions it might raise. So this is a code snippet on how we document our code. Like I previously mentioned, we documented using docstrings. So this part here, the green part, the green part, the comment part actually, is what a docstring is. So whenever you use this method here, and then whenever you hover over it, it will like have a pop-up that tells you that displays this docstring as well. So that's how we documented our code. This is an interface, and then before an actual implementation of a method, we just made an interface so that we can like document everything in that interface to make the code a bit more cleaner. Alright, so for documentation that reflect that tests can be run on the code and their purpose, we made use of a README file. So our README file has instruction on how you can run the test. Alright, so this is our README file, and then here's an instruction on how you can like run the test. So it refers you back to the script, and then when you on your terminal, you can make use of the terminal to run your test. Make use of the terminal and the script to run the test. So it's bash and then Brownfields .sh and then test to run our test. And then the script will take care of running the test for you, and it will run each and every test, including acceptance test that exist on the program. So these are just messages from the test that we are currently running. The results will be displayed after it completes running this. And then this another way you can test if the test are passing is by looking at your pipeline, checking the pipeline. So these are the results actually. Results, and then it ran like 51 tests, and then no tests are failing, zero errors, and then no test was skipped. So the build was successful. So if we go back to our GitLab and we navigate to the main branch, we can see that we have like different stages in our pipeline, and then one of the stages include unit test job. The unit test job has passed, meaning all the tests were passing when this commit was made.
Hello, my name is Wanda Anna, and I'll be taking you through the database management systems. So does the presentation describe the problems represented by data management issues and include examples. So we have data privacy, so failure to protect individuals' privacy rights and comply with privacy regulations can damage the reputation and result in legal consequences. Then we have data security. Inadequate security measures can result in unauthorized access, data breaches, and loss of sensitive information. Then we have data storage and retrieval. Inefficient storage systems and retrieval mechanisms can lead to slow query performance and hinder timely access to critical data. So does the presentation describe ways that a database management system can solve problems represented by data management issues? So data privacy, by using data masking techniques that help to hide personally identifiable information in non-production environments to prevent unauthorized access of information. Then we've got data security by using role-based access control to ensure that only authorized users can access specific data tables to perform certain operations. We've got data storage and retrieval, using indexes to speed up data retrieval operations by enabling fast lookup of records based on specific criteria. Does the presentation describe ways in which each feature of a commercial database management system contributes to the solution of data management issues? So we've got data privacy by using anonymization, replacing identifying information with pseudonyms or generic identifiers, preserving privacy while still allowing analysis and reporting. Data security, using access control, which allows administrators to define user roles and permissions, ensuring that only authorized users can access specific data. We've got data storage and retrieval by using partitioning, that's dividing large tables into smaller ones and then making them into more manageable partitions and improving performance and scalability. Does the presentation describe the purpose of commonly implemented features of a commercial database management system? We've got data definition language, which is used in the definition and manage the structure of the database schema like create table. Then we've got the uh, data manipulation language, which enables users to query and manipulate data that's stored in the database. For example, you've got your select, your insert, and update statements. Does the presentation describe the characteristics of different database management system types? So relational database management systems organize data into tables with rows and columns. They enforce data integrity through constraints like primary keys and foreign keys. Then we've got NoSQL database management systems that are designed for unstructured or semi-structured data. So for flexible schema allows for dynamic data models. Then we have in-memory database management system. They store data primarily in memory for faster access and lower latency, and is suitable for high-performance applications requiring real-time, uh, requiring real-time data processing. May offer durability features like persistent storage or replication. So does the presentation provide examples of the use of different types of database management systems? So there are relational database systems that store information in related tables. For example, we have for this one world data. The world data includes the configuration of the world, its size, and then the relational uh, the relational tables, which includes its mines and obstacles that are then stored as the other things that are contained within the world. Then we have the memory database management system, which is used to store frequently accessed data to decrease the latency of fetching data. For example, um, if we wanted like a user count, like a live user count for the people that are logging into the system or watching something. Then we've got a NoSQL database management system um, that is used for content management systems that can store articles, images, and user-generated content due to its flexibility. So does the presentation identify and describe features and limitations of database management system and user tools? So features of database management systems include graphical user interfaces, got builders for useful things like queries or forms, as well as reports. You could also build database schemas, tables, and relationships that can be generated by non-technical users. So limitations of database management systems include limited functionality, only simplified functionality is available. So vendor lock-in also happens where the database management system can only be used in a specific platform, and it might prove challenging to migrate to a new database management system, as well as a steep learning curve that each database management system can have. So does the presentation identify and describe the use of database management system and user tools? Some database management systems offer business intelligence and data analytics. Others allow for seamless integration with other productivity software and usually help simplify and meet the needs of non-technical members who would like to create, access, update, and or delete data. Does the presentation identify and explain the requirements for database access for your project? So data access for this project is for the server to be able to save a world. So a world basically consists of its size and the positions of all of the obstacles, mines, and pits that exist within the world. So as well as being able to store other worlds that have been created by other creators. That's the data needs of the particular project. So does the presentation identify the database access objectives and critical performance factors of your project? So for this project, only the server is allowed to save a world of the robot worlds, and then the API server as well as the robot server are allowed to restore a world that eventually failed. So does the presentation showcase a database design structure that implements user requirements? So the requirements of the game is that the server is able to save worlds, and then each world has its particular obstacles, pits, and mines that then make up the complete world. So the user requirements is to have a world. So then the world is then related to all of these other obstacles through its primary key and foreign key. Does the presentation showcase a database design that caters for the program's data needs? So the data needs of the program will be met because we'll be able to save any world with its particular name of the world that the user chooses, and then we'll be able to store the obstacles, the pits, and the mines of that particular world at any point in time when the user requires to save it. So does the presentation showcase a database structure that shows that each table in the database adheres to the third normal form? So all of the tables adhere to the third normal form. There is a main table that is then used to keep track of all of the that has a primary key, of which that primary key is then used as foreign keys for all of the other related tables. For instance, we have the world that has a world ID, and for each obstacle, pit, and mine, each specific world will be related to specific obstacles, pits, and mines that are there through the foreign key, which is the primary key of that specific world. So does the presentation identify key relationships between tables within the database structure design? So the relationship between each table is through the primary key of the world table. So each obstacle is related to a world. So one world can have many obstacles, it can have zero or many obstacles, zero or many pits, and zero or many mines. So all of the other tables of obstacles and mines are related to the world table through its primary key, the world's primary key, and that world's primary key becomes the foreign key in the obstacles, the pits, and the mines. So then that then shows the relationship between the other tables in relation to the world table. So does the presentation showcase database primary and foreign key consistency throughout the database design structure? So every table consists of a primary key, and then all of the tables that are then related to the main table all contain foreign keys that relate back to one of the keys from the world table, in this case the primary key world ID. That then relates all of the obstacles table, the pits tables, and the mines table. Section D, evaluating SQL implementation and data management in web applications. So does the demonstration showcase the implementation of the program design for a program using SQL? So the program design is then implemented using SQL statements. For instance, in creating tables, we've got SQL statements that are then there to help create the worlds that were depicted on our UML diagram. So the SQL statements will then create all of those tables as per the requirement of the project. Does the demonstration showcase SQL code that is understandable? So the SQL code is understandable in that there are aliases that are given to worlds when you're trying to select information from a particular world or particular table. So these aliases make it easier for it to read. For instance, world gets an alias of W and obstacle gets an alias of O. And then those are used appropriately when we want to reference a particular table by using the alias of O and or W. And then the way that SQL statements are structured is such that like the main SQL statements are then formatted in such a way that they are more consistent with SQL query statements. So does the demonstration showcase the use of SQL functionality that optimizes queries? So in this particular instance, join tables are used to help optimize select queries. So select queries are for finding information on the table. So instead of just getting everything from everywhere, so we use join tables in order to make sure that we put together only the information that we're looking for and then select for that information. For instance, this one joins worlds, the worlds tables with the obstacles tables, where the where the world ID and the obstacle world ID foreign key meet. Then that puts together both of those tables to then give me one set of table with information about what the obstacles are. So table joins being used for optimizing SQL queries. So does a demonstration showcase SQL functionality that makes SQL code understandable? So this consistent naming convention, um, SQL code is commented and the SQL code has relevant aliases. So you commenting about the SQL code that helps tell the person going through it what that particular piece of code is doing. So this one is for retrieving data from the mines, from the relevant world. Then this is retrieving PITS data from the particular relevant world. And then the naming convention, uh, where we use relevant aliasing for the pits, worlds, mines, and obstacles. So does a demonstration showcase the necessity of each join SQL query? So each join table is meant to extract specific and relevant information without going through the whole database in order to get the specific information that we're looking for. So then that then helps optimize the queries. Does the demonstration showcase the use of SQL functionality that preserves the integrity of data access by multiple users and processes? So the use of SQL functionality, including transactions and foreign key constraints, that helps preserve the data integrity of using a multi-user environment. So as had been shown in the beginning, that there are primary keys as well as foreign keys for each and every table, but then make sure that when retrieving information, it stays consistent. Then we also make use of committing transactions once the transactions have been finished in order to make sure that there is consistency with the data integrity. Does the demonstration identify the methods of accessing data for your program? So there are two things that were done. One was create objects that contain attributes, setters and getters for specific data that allow that data to be stored, retrieved, and then passed around. For example, the world configuration, where that stores the particular information, like setters and getters, as well as the size of the world, the name of the world, information about that world that then will be used to be passed around from the database to the program itself. Then we've got the database management system that has methods that are relevant to the specifications of the project. In this case, the specifications of it was to save a world as well as being able to restore a world. So then we created methods, but then also before we are able to do any of the saving and restoring, we'd have to create or make sure that tables are created if they don't particularly exist. So then there's a method that's there for creating a table. Then there'll be methods for saving a world as well as restoring the world. So once a world has been saved. So does the demonstration showcase good use of data sharing within the application? So because we use different classes to transfer different types of data around, so we use like the world config in order to store and pass around information about the world. Then we use pits and mines in order to retrieve data. Like we've got like a pit class that then helps store the X position, the Y position of a pit, as well as its length and its X length and Y length of the pit. So such objects are then there to help move around the data. So as for mines, the X and Y positions of the mines are then there to help store and transfer that particular information around. So does the demonstration showcase the underlying technologies that link databases and websites? So for linking databases and websites, we've got the front end that makes the website, the front end, which makes a request to the API server. Then the API server then links to the database manager and then gets the database manager to make queries to the database. So in this particular one, we would have an API server that then is linked to the API handler, and then the API handler then makes requests to the database manager. Then the database manager makes the necessary queries, either restoring, for this particular case, because the API server is meant to just restore the world, it then calls upon the method for restoring the world, and then the method of restore world then runs all of the SQL queries. Uh, so there we have our API server. So in this particular one, for retrieving the world from the database, uh, there is the endpoint of /world/ put in the world name that you'd want to restore. Then the API handler then goes to the method of get world. So the get world method then calls upon the database manager and then restores, of course, the method to restore the world from the database manager. And then if that is successful, that information about the world is then stored in the world config class. And then if the request is successful because the world actually exists, then the world config class then contains information about the world. Then if it isn't, or if it does exist, it is then sent back to the front end, which is the person, which is yeah, the person or the technology that then access the information that gets sent back to that as a JSON string. And then if the world doesn't particularly exist, then what gets returned back to the class or the technology that called or made the request to the API server is a world not found status. And then does the demonstration showcase methods of linking web pages back to and does demonstration showcase methods of linking web pages to backend uh, proprietary applications? So the front end would make requests to the API server, and the API server is linked to server sockets by connecting new sockets to the point or to the port of the server socket that it is connected to. So the API server connects to the API handler, then that API handler connects to a robot world JSON client that then connects to a multi-servers, and then the multi-server connects to a simple server at port 5000. And that's how the REST API server is then connected and linked to the back end of our project. So does the demonstration showcase code that is commented? So all of the code has been commented to show exactly what the code does. in this particular case. Commented code from the database manager. There's also code that is commented to tell you what it does, doc strings, to make going through the code a lot more readable for the end user. So that concludes this section about database management systems. Thank you very much.
Greetings everybody, my name is Gugulethu Mokwena and I'll be doing section E of our project. So I'm just going to cover the testing part of everything in terms of how we executed it, how we planned it, and how we went forward with testing for our project. So let's get started. So first we're going to start by asking, does the demonstration showcase the execution of operational steps identified in the test plan, right? So I'm just going to show you how we followed the steps in terms of our test plan, right? When we got the documentations, we were required to write stories. So stories were all the test cases that we will account for in terms of all our project. For example, this would be the look command story. It have a title, we're looking around in the world, and a narrative. So a narrative is just a broad description of what that specific command would be doing. So this command says, as a player, I want my robot to look around anywhere and at anything in the world so that I can be aware of all the objects in my vicinity. So the player wants to be able to see everything, and in terms of the look command, right? Then under the narrative, we have different scenarios. So the different scenarios now are the specific test cases that we're going to be using within our project. And for every scenario that we created, we then went and we created specific tickets under a milestone being the bigger picture of that specific ticket, and then those bigger pictures now broken down into smaller pieces, which would be the tickets that we assigned ourselves to, and we actually now go do the testing. So as you can see here, we have the valid look command, see robots obstacles, see pits, see everything, right? So this is the tickets that we have. Then you assign yourself to the ticket. What you do then is you go to the project, then you come here, go to test, and we were by the look command. So as you can see, this is the narrative. As a player, I want my robot to look around anywhere and anything in the world so that I can be aware of all the objects in my vicinity. And then from there, these are now the different tests that you find under the different scenarios that you find under that story, right? Look should show me other robots, the edges, and so on and so on. And that's how our planning was executed. Our test planning was executed, from creating stories to creating tickets to then executing those tickets in creating the tests. Cool. Next. Does the demonstration use input data as specified in the test plan during the test, right? So what we actually are saying here is, did we use the correct data in terms of our project, then the test that we put? So all the data that we use in our tests, does that same data be able to use in our project, and is it used correctly, and is it giving the right errors if there are errors? So let's go test for that. Let's go, for example, back to our project, and let's say we want to launch. Let's go for launch, right? So we are here now. We want to test if we've used the right data. So here, let's go for valid launch should succeed. So this is testing for positive, meaning that when we launch a robot, how it needs to be launched, it needs to give us an okay result and all the data that we ask for here in terms of the position and everything that we see. So if, for example, now I run this, let's see. This is great. It runs properly. Submission study sends back. This response is normal, and then this is the result. Okay, data, shield, visibility, range, position, and so on. The position, the shots, and the status, and everything. So this is just our test. So let's go now test if our project works the similar way. So let me just close this. We open it again. Cool. So we're just gonna split it so that we can run the server on one side, and then we will run the client on the other as soon as the server is up and running. There we go. Our test is coming up. Let us now run our client. And then what we're going to do is we're going to use the same demo data that is here in our test, so we can see that it actually works properly and it gives us what the test would be looking for, right? So we're running our client now, just waiting for it. Okay, client has been added to the server. There we go. Then it gives us instruction, launch your robot using this format. So we are gonna launch HAL, as it says, and HAL is a shooter robot. So the response is normal. The result is okay. This is the data that shows the visibility as shown in our test case, the position, the shots, and everything else. Status is normal as well. Then that is the same thing that we find the side, meaning that we did use the correct data in terms of how we planned to test the project. Moving on. Does this demonstration outline deviations from the test plan with explanations during the testing? So I think one thing that we deviated from in terms of testing and how our test plan was the database tests, right? So if, for example, let me just go back to our stories. Remember, for our stories here we have a subtopic. So every subtopic here had to be like a specific file, the one that we now test for, in terms of the iteration that we were in. So we had to now, for this iteration, test for save and restore. But as you can see here, when you do look at our structure, it doesn't have like a specific database save file and a specific database save folder, but it does have like a specific look, a specific launch as specified at the top. And we did create the stories and we did create different tickets for it, but when we realized that when now writing the tests, it was a different story, because in a way we couldn't make them separate. We couldn't separate saving and restoring a world, because the tests weren't working properly, because in order to restore a world you had to save it. And what we do in our test is we start the server there and we close the server in the test, within the test itself. So if we start a server and we save it and we close it to start a server again, it becomes a lot complicated. So what we did, one deviation was, this is where we didn't follow the standard of our tests, but we did cover everything that we needed to test for. So for our database, what we did was we came here and we just created one test, but it had everything in there. So it would create the world that we want to save. okay, let's say the name of this world, I'll call it dummy. Cool. And then saving the world, and then trying to restore the world, and then checking if it has been restored. So if I were to run this, okay, let's just wait. Oh, okay. So also let's see, let's just wait for it. Cool. Let's just go back the side. Let's see. We're just waiting for it to run, but essentially it's gonna do all that, and then yeah, that's the one thing that we deviated from, but it does test for what we were looking for in our stories, and it does work how we needed it to work. It's just that we couldn't separate it the way we did every other test that we created. Cool. Going back to the next one. Okay. Does the demonstration follow the standards and procedures specified in the test plan for testing and retesting? So yes, we did have, as I mentioned, we did have specific structures that we did follow in terms of the the stories and creating tests and everything like that, right? If you can see here in terms of the structure, okay, the database, just database, everything that we wanted to test for the database would be under the database tests. Launch robots would be under the launch robot tests, and everything that had to do with robots generally would be under the robot folder. Everything with the server, anything that had to do with the world with the maze in it, and anything to do with the API. So we structured our tests like that so that we know which test follows what exactly, and those were the testing rules that we came up with, and this is how we stuck to them, and it made it easy for us to test and retest anything, because you would know if you want to add a database test, you'd go that the database has to do with the robots, and inside robots there's a database, and that's where you add your database tests. So yes, that's how we structured our work, and those are the standards that we put in place for testing and retesting. Does the demonstration showcase the testing of program logical paths? So with this one, let's just go back to the project, right? This logical paths, meaning did we try our best to cover everything that is there? Did we test the project in different ways, on ways that it works? For example, here we have the mine. So with this, we tried our best to test positively and to test negatively. Within positively meaning for every successful test, and negatively would be any negative test that would be there, and how we handle it, for example. So here, as you can see, we have the valid mine command, so meaning this is a successful positive test when we actually mine, when a robot that's supposed to mine mines, and this is it mining it, and it would be successful. And then we also tested if what happens when a robot gets hit by a mine. We tested for the negative robot with no shots set mine. So this just means that we tested for a robot that is not able to mine. What happens if a robot that doesn't mine wants to mine? So there's a set of an error that they need to get back without breaking our project. So this is what we did, and that's how we covered all the aspects that we needed to cover in terms of our logical paths of a specific command. Next, Does the demonstration showcase the elimination of errors identified through the testing of database access using SQL? Okay, so if I were not to go back, so our SQL is actually up here. As you can see, we have all our statements up here, and what we did actually was we accounted for these. We accounted for these in the server side, which I will show you. But this is where our SQL has been there. But as you can see, it draws an execution. Create world has been failed if we couldn't create a world. If the world and the obstacles was successful, if the world already exists, and all of that. So if, let's say for example, I go back to the database test and I try my best to I create the dummy world again. Remember, we've already created a dummy world, so we're supposed to get an error that the world already exists, right? Let's see. There we go. World already exists, which was here in our manager. So as you can see, this is where we are accounted for it. So this is how we did fix our database errors, and this is how people would receive their errors. Moving on. Cool. What's next? Does the demonstration verify through testing that database access performs according to the requirements? Okay, so let's see. Does demonstration verify through testing that database access performs according to? Okay, so we did demonstrate in terms of the database that database file that it works how it's supposed to, but for for the iteration, all we needed to test for was the two commas that we had, which was the save and the restore. If we can just go back to the file. As I said, we just have one specific data file, database test, and it does everything in here, right? So yes, we did test the database in the right place. As you can see, it was able to communicate with the database in a way. We do create like a new database manager where we are able to now get those specific commands to be able to communicate with the database. So moving on, does the demonstration verify through testing that database access functions according to requirements? So let's just now go and we test it out. I did think I showed you earlier. This is how you check if the database works properly. This is just for the world. I'm gonna just run it again. This is just for the world that we already exists, right? This is for a world that is new, that is recently created. And then instead of world exists, it will say world has been created. And this is how you know that our database does work properly. And there we go. There we go. Then reason is also I'll just keep coming back to demonstrate the database in full detail in terms of the other topics that are there. Does the demonstration provide records for all tests executed during the testing of the computer program? So we actually, as I said earlier, we created a document that had all our tests and all that. If it's executed like this, what should happen? What would the results of that be? And with this, we went and we created tickets from that. So we understood exactly what was needed from the project and how we would go about testing it and what results we're supposed to get back. So this is how we recorded everything in terms of our project. Then now going forward, does the demonstration identify variations from expected test results from testing a computer program and give reasons where available? So if, for example, now we go back to our and we go to launch. What is this? I want invalid launch. So here we go. Here we're just testing for the negative. So this is just the differences that we get in terms of our results. The only differences that we get. So on our launch command, for invalid, if I run this, okay, so what it does is it just says message, this is the message that it sends, and then it just shuts down the server. But if we do it practically in our project, it gives us a very different output to the one that you see on the test side. So for example, on this side, it just has to tell you, I'm going to use the same demo data that is in the invalid launch command. So just to show you that that's the differences that we have in terms of the results that we get back in terms of testing and the actual project. So example now, cool. So let's say now I want to launch Helm, who is a shooter. And I press enter. On that side, it didn't really give us this error here. See, result to error, data, and then message unsupported. On the other side, we didn't test it like that. It just gives us what was sent, the message that was sent to the database, and not the result that we get back. Okay. Does the demonstration show that recorded results can be reproduced if the tests are repeated under the same conditions while testing a computer program, right? So is valid launch. Let's see. So launch, we're in launch, okay. So valid launch, as you can see, we've launched HAL, and we can launch HAL over and over and over again, and it would not HAL exactly, but different types of robots, and it wouldn't give us a problem. But here, as you can see, robot with same name. Then if let's say we launch HAL, yeah, and then we go and we launch HAL again, as you can see, it will give you too many of you in the world as an error. So repeated tests just to confirm the results. We repeat the same input just to show you that it does give you the same error back, because you'll be launching the same robot choice. And if I were to now run this, it will pass. So, okay. Let's. There we go. Come here. There we go. Perfect. Then does demonstrator record results in a way that allows the results to be reviewed while testing a computer program? So as I've showed you, some of them do work properly in terms of giving us a good result in terms of what is giving us on the client side, but some of them not so much, as I've demonstrated it. So it's a 50-50 give or take situation. Does demonstrator allow improvements to be made to the application? So we could a lot of improvements could be made. For example, separating certain, like the database tests, having restore alone, having save alone, as we initially planned in our tests plan, and the some of the results that we get back that don't show properly, the results that a client sees, that can be improved on. There could be more test cases that can be added as well, in terms of just the reviewing process of the testing process. And I think there's more steps we could have added in terms of the planning, in terms of reviewing each other as well, in terms of the test that we have wrote. So those are some of the improvements that can be made in our project. Then, does the demonstrator follow organizational policies and procedures while conducting a review of the testing process? So just to show you what the policies were, if we can come here, we had to create acceptance tests, and the way we followed the how they'd like us to have done it. Just gonna come here. So what they needed to do is we did start by testing first. So what we mean by this is we started writing the tests first before we even write the code, right? Because the code is supposed to work according to the tests, not the other way around. And then we had mock dependencies, but we didn't remove them as well. And we kept testing. So for every code that you would write, you would test regularly, so that if it fails, you change whatever you need to change, and if it passes, it means it works properly. So we needed to start by writing a story, which is the ones that I showed you, that document that we had. We wrote the stories according to this structure as well. Then we represented the story into code, but we added a step where we took those stories first and we went and we put them into tickets first. But as you can see in our project, we do have comments of test after launching 2 robots, as they have required us to do in terms of let's go back to the side, in terms of turning, can you see that, in terms of turning the stories into code, and we did do that, and that were the standards. We did we did run it against a reference server, which we had to then remove later on, but we did follow this step by step, and we added more steps just to make it easier for ourselves as well. Then I think I have now covered everything. Thank you very much, and passing it on to
Good day, I'm Sihle Ndlovu, and today I'll be closing off the presentation by discussing Section F, ensuring consistency and adherence, evaluating documentation and design in computer program presentations. Firstly, I will show that we created documentation for our project. But before that, let's discuss the importance of documentation. Documentation is crucial in software development. It helps developers understand and collaborate on projects. It also keeps important information organized and accessible. In simple terms, documentation is essential for successful software projects. In software development, various documentation types serve critical purposes. The README file, code comments, and user manuals collectively ensure clarity and facilitate effective collaboration. Now let's dive deeper into all of them. The README file provides an overview of the project, installation instructions, usage guidelines, and other relevant information. Code comments. They display snippets of code with comments explaining the logic, algorithms, or functionality. The user manuals or guides present any user-facing documentation, such as user manuals or guides explaining how to interact with software. Now, this here is a screenshot of our README file, which states the overview of the project, the installation instructions, and a brief explanation of the key concepts and features. This is a screenshot of our Robot World client class, which displays comments that explain the aim or purpose of the block of code below it. Secondly, I will present our plan and design. In this section, we'll discuss our software project's plan and design. We'll show how our initial design decisions guided the creation of documentation and evaluate its alignment with our established design standards. Now, this was our design. This is how we had planned to execute the project, and it's how we did execute the project. Now, all documentation within our code adheres closely to our design standards, providing clear explanations of each feature's purpose. This ensures seamless collaboration and makes it easier for subsequent individuals to understand and build upon our work. Thirdly, I will review our documentation. This is a screenshot of our API handler class. This also displays how the comment has the aim of the block of code below. Like this one, it reads, retrieves the configuration of a specified world from the database and sends it as a response, which is what the code below does. Now, packages help us organize code neatly, making it easier to understand and reuse. When we document packages clearly, it helps everyone on the team understand what part does and how they fit together. Good documentation makes it easier to work together and build software that lasts. This is a screenshot of how we packaged our classes. Here on the left-hand side, it shows that all our packages are in the Java folder, pardon me. And we also have the test folder, which is where all our tests were in. Now here I have opened the client package to show all the classes that were inside, and those were the classes that had to do something with the client. This is a screenshot of our make file, which also shows how we documented our stuff, because it also has clear instructions of how to use the make file. Now, according to Google, the proper way to document your code is 1, to add comments to your code, which we've done. 2, to write test cases, which we've done. 3, to provide a suitable Git commit message, which we've done. 4, maintain proper README file, which we've done and I've displayed to you. And 5, write a self-documented clean code, which now is visible in the code itself, making sure that you do not repeat yourself, and also the variable names and so forth. Thank you for watching our presentation. Have a great day.